Hello everyone and welcome back to my YouTube channel. I'm Naina Priya. I'm from Sri Venkateshwara College of Engineering from the Department of Artificial Intelligence. Today's subject is data structures and algorithm and topic optical binary search trees in data structures. Introduction. Optimal binary search tree are a data structure used for efficient searching. They provide a way to organize data in a binary tree to minimize the cost of searching. This structure is particularly useful when the search frequency of elements varies. Binary search trees. Binary search trees are a data structure where each node has most two children. The left child of a node contains smaller element and the right child contains greater element. Searching in a binary tree has an average time complexity of O of log n, where n is the number of elements. Cost of searching. The cost of searching in a binary search tree depends on the depth of the node visited. The goal is to maximize the average cost of searching by arranging the tree optimally. The cost is typically measured as the number of comparisons needed to find an element. Optimal binary search tree. Optimal binary search trees minimize the average cost of searching by arranging nodes optimally. The optimality is achieved by considering the search frequencies of the elements. Most frequently, search elements are placed closer to the roots for faster access. Dynamic programming approach. The dynamic programming approach is commonly used to construct optimal binary search trees. It breaks down the problem into smaller subproblems and solves them recursively. The optimal solution is built by combining the solution of the subproblems. Subproblems definitions. The main subproblems is constructing optimal binary search tree are defined as follows. Choosing a root for a subtree, constructing optimal binary search tree for the left and right subtrees, determining the optimal cost for a given subtree. Your second bullet, your third bullet. Computing optimal cost. The optimal cost of a subtree is computed by considering the cost of its left and right subtrees. It also takes into account the probabilities, search frequencies of accessing the elements. The cost computation is done recursively from the bottom up. Constructing the optimal tree. Once the optimal costs are computed, the optimal binary search tree can be constructed. This is achieved by selecting the roots for each subtree based on the computed costs. The process is repeated recursively until the entire tree is constructed. Time complexity. Constructing optimal binary search trees using the dynamic programming approach has a time complexity of O n to the power 3. Here, n represents the number of elements in the tree. This complexity arises due to the need to compute optimal cost for all the possible subtrees. Space complexity. The space complexity of constructing optimal binary search tree is O of n to the power 2. This is because of matrix of size n into n is used to store the computed cost. Additionally, arrays are used to store the probabilities and other necessary information. Advantages. Optimal binary search tree improves search efficiency by minimizing the average cost. They are particularly effective when the search frequencies of elements vary significantly. The dynamic programming approach ensures an optimal solution based on the given probabilities. Limitations. Constructing optimal binary search trees requires knowing the search frequency in advance. If the probabilities change frequently, the tree may become suboptimal. The dynamic programming approach may not be suitable for very large data sets due to its time and space complexity. Applications. Optimal binary search tree find applications in various domains, including compiler design for efficient symbol table lookup, the database system for indexing and searching, natural language processing for efficient word lookup. Conclusion. Optimal binary search tree are a valuable data structure for efficient searching. By arranging nodes optimally based on search frequencies, they minimize the average search cost. The dynamic programming approach allows for the construction of optimal trees effectively. References. Thank you. Please like, share, and subscribe.